Okay, so in this lesson we have limit as x approaches what 0 of sine theta over theta, which is equal to 1, and limit as x approaches 0 of cos theta over theta, which is equal to 0. Now many students see these particular things in their textbooks and ignore them. Now there's a way to evaluate these things. There's a way to check or to prove if to prove how limit as x approaches 0 of sine theta over theta is equal to 1, and limit as x approaches 0 of cos theta over theta equals 0. Now how do we prove it? So now we prove it using a rule called L'Hopital's rule. So we prove it using the L'Hopital's rule. So this is the rule we are using, the L'Hopital's rule. Now what does the L'Hopital's rule say? So the L'Hopital's rule says, given we have a function f of x and another function g of x. So we have these functions f of x and g of x. Now if f of x divided by g of x, taking the limit as x approaches a, if f of x is divided by g of x and the limit as x approaches a is taken, and we obtain either 0 over 0, so and we obtain 0 over 0, or sometimes infinity over infinity, we can use what? The L'Hopital's rule. So we can use the L'Hopital's what? Rule. So basically the L'Hopital's rule focuses on this. The L'Hopital's rule focuses on this. So if you are getting a limit as x approaches a of f of x over g of x, where it's giving us 0 over 0, you can apply the L'Hopital's rule. And also if you are getting b over 0, you can apply the L'Hopital's rule. You can apply the L'Hopital's rule. So L'Hopital's rule basically deals with what? If you are getting an undefined answer. So we call this undefined. So if you are getting an undefined answer, you can approach or you can use the L'Hopital's rule to solve that particular limit. So that's what you're coming to prove what? Limit as s approaches 0 of what? Sine theta over theta, which is equal to 1, and limit as s approaches 0 of cos theta over theta, which is equal to 0. Now back to the L'Hopital's rule. There's more. Now this rule is saying that if you have an undefined answer, you can use it, right? Okay. Now in this particular rule, what it does is that you are going to differentiate the functions. So for the L'Hopital's rule, you are going to take the limit as s approaches 0, a, of your f. You're going to differentiate f prime of x over g prime of x, right? So limit as x approaches a of f prime of x over g prime of. Now take note, you are going to differentiate the functions as it is. So let's take a quick example before we go. So if let's say limit as x approaches a, and you have x squared minus 8 over x minus 2. Now let's say a here, we don't want to actually say the value of a. We are just doing a quick way of how to differentiate this. So let's say this here is our f of x, and this here is our what? G of x. And let's see, when you put a into it, we get what? An undefined answer. So look at how the differentiation will be done. So we are going to differentiate. So you don't differentiate as you are differentiating a fraction in differentiation, right? You differentiate just the top, just the down separately. So you are going to what? Limit as x approaches a of now x squared minus 8. The differential of this is 2x over x minus 2. So when you differentiate x, you get what? 1. So we now get limit as x approaches a of 2x. Limit as x approaches a of what? 2x. Now most people, when they are told to differentiate this thing, they go ahead to do something like this: x minus 2 all squared. Please, this approach, x minus 2, they go ahead to do x minus 2 all squared, then 2x into brackets the x minus 2, then minus the x minus 2, then minus the x squared minus 8, x squared minus 8, multiplying 1. Please, this is not the procedure or method for doing the differentiation using the L'Hopital's rule. So please don't confuse yourself. So now let's do what we're about to do. So now let's take limit as x approaches 0 of sine theta over theta, which is equal to 1. Now I come to actually know if this will give us 1. So we are taking limit as x approaches 0, limit as x approaches 0 of sine theta over theta, right? Okay, so now we can see that if we substitute 0 into this particular function, we are going to get what? 0 over 0. So hence we can approach the what? The L'Hopital's rule. We can do what? Approach the what? L'Hopital's what? Rule. Okay. Okay. So now what we are going to do is that, so we are taking limit as x approaches 0 of sine theta over theta. So the first thing we do is that we differentiate our sine theta, differentiate our what? Theta. So now limit as x approaches 0. So I differentiate everything with respect to theta. So when you differentiate sine theta, we know that it is what? Cos theta. So we get cos theta over. Now when you differentiate theta, you simply get 1. So our limit as x approaches 0 of cos theta. So this also remain. So now we come and get what? Limit as x approaches 0. So now when you substitute 0 into this particular thing, so of cos what? 0. So limit as x approaches 0 of cos 0. Now cos 0 is what? 1. So cos 0 is equal to what? 1. So now you can see why limit as x approaches 0 of sine theta over theta is equal to 1 because of the L'Hopital's rule. Now the next one was limit as x approaches 0 of cos theta over theta is equal to 0. Is equal to what? 0. Now we differentiate. So limit as x approaches 0. Then the differential of cos theta is negative sine theta. So negative sine what? Theta. Over now the differential of theta is what? 1. So over 1. So we come and get limit as x approaches 0 of negative sine theta. Of negative sine theta. So our answer will be limit as x approaches 0 of negative sine 0. Of negative sine 0. Now we know that sine 0 is what? 0. And 0 times negative 1 is also what? 0. So our final answer will be 0. So now you can actually see limit as x approaches what? 0. Of course, theta over theta is equal to what? 0. Is equal to what? 0. Right? So please, if you want more videos under maths, under science, and under history, so just click the subscribe button. Click the subscribe button for more videos. Thank you.